Welcome to this image analysis demonstration of the Microtrac Dry Image Analyzer, unique in producing three-dimensional results. It offers two range options, 30 microns to 15 millimeters and 50 microns to 35 millimeters. Rarely is sample prep required, just pour the sample into this funnel which feeds onto the vibratory feeder below it. This sample is plastic flake, which has interesting morphological properties. Here's our plastic flake feeding into the analyzer. And you can see the particles tumbling down through the sensing zone. The moving lines are an artifact of the non-synchronization of our video camera speed and the strobe frequency. A photo is taken with each flash of the analyzer's strobe light. Multiple photos are taken of each particle as it tumbles through the zone. This captures many views or orientations of the tumbling particles. And that's what gives us the three-dimensional data unique to this analyzer. Some examples of other types of samples, like half spheres. Here are some uniform hollow cylinders, which might suggest the three-dimensional monitoring of machine parts. And finally, a very fragile sample which wouldn't be broken or deformed by this type of analyzer. And this is the slow motion view of the tumbling particles taken from behind the analyzer's optics and digital camera. You've seen a demonstration of how the Microtrac Dry Image Analyzer works, and that it's very simple and easy to use. Now we'll take a look at the software to point out the quantity and quality of the 3D morphological information that it provides. Here's a graphical view of 6 different parameters of the plastic flake sample, all plotted in several different ways on the XY graph. And if you take a look at the key up here in the upper right-hand corner, you can see that we have plotted the area diameter equivalent in a cumulative percent passing volume distribution. We've plotted the width in a differential volume percent distribution, the maximum distance in a differential volume distribution, the minimum distance down here in a differential volume distribution, and the length in a greater than volume distribution. And the width in curve number 6 as a differential count percent or number distribution. And you can plot any of these curves using any of these combinations of choices shown below the graph. This is the tabular distribution information for all of these curves. These channel sizes and all of the choices for the graph parameters are set up in the SOP, or the standard operating procedure. You can also plot shape parameters on the XY graph. Here we're plotting circularity, this parameter here, on the y-axis. The shape factors are ratios of size parameters and are all normalized to a scale of 0 to 1. For circularity, 1 would be a perfect circle. On the x-axis, we're plotting the size of the width parameter in microns. So we see two modes of high circularities at widths from about 20 to 100 microns and between 200 and 2,000 microns. Finally, you can display up to 6 different samples with the same parameter selected from historical files for comparative purposes. Just click off the current result box, then click Get Result from File, and browse to the records that you want and open them in the XY graph. Here's another parameter distribution display called a scatter diagram. This feature can provide additional useful information about the morphology of the particles. Any size or shape parameter can be displayed on either of the two graphs above the x-axis or to the right of the y-axis, the scattergram itself. The scattergram shows the position of every particle measured relative to the two parameter distribution graphs. Darker areas are areas of higher particle concentration. Any size or shape parameter can be chosen to be shown on either graph by using these windows. This window for the X graph, and here are all of your size and shape parameters which you can choose from, and this window for the Y graph, and again all of the size and shape parameters that you can choose from to plot on those graphs. To the right is a long list of summary data for each graph, and all size parameters can be displayed in both the number and volume formats. So we have the area equivalent diameter, or DA, displayed on this x-axis graph, and we can convert that from the number distribution that it's in right now to the volume format. And you see this large mode of high population density get much smaller when it's in a volume distribution. The DA, area equivalent diameter, and circularity, a shape factor, are displayed here now. We see two small secondary modes, both in the x-axis, the DA parameter, and in the y-axis, the circularity parameter. An area of the scattergram diagram can be selected which will isolate those modes from the total population and give us summary data for only those particles. If we highlight the area where the secondary modes exists, we can see that we've isolated those particles in those secondary modes, and now all of the summary data has changed to indicate data just for that area of the scattergram, just for those particles. And we see that now the mean volume diameter for DA is 494, the mean number diameter is 486, and for the circularity, the mean number is 0.24. And now we have only 658 particles represented here in these distributions, where before we had over 1,000. This is a powerful tool that can be used to isolate a group of areas, sort and filter particles, create classifications of different compounds in the sample, and develop and use morphological models. In the View Particle screen, we can see the images and all the size and shape parameters for any particle we choose. Each image in each row of the image file represents only one view or orientation of one particle tumbling through the sensing zone. The DIA then has the unique ability, patented, of calculating all three major dimensions of each particle for the only 3D image analysis available. Here we report not only the length and the width, but also the thickness, the third dimension of the particle. Again, unique to the industry. This concludes our demo. For more information or to contact us, please go to microtrac.com. And thanks very much for viewing.